students, welcome you all in my YouTube channel Pacific Chemistry classes. Students, today we will study some basics of our halogens and I will explain the geometry of our IF7 molecule. So students, if we talk first the geometry of IF7, so we know that it is pentagonal bipyramidal, and which hybridization it will go sp3d3 hybridization. So we know that IF7, whenever you start with IF7, thoda sa it takes time na. What is the atomic number of iodine? So what is the atomic number of iodine? It is very little tough. That iodine is having 53. So we know the geometry, but if you don't remember the atomic number of iodine, you will forget the how you have to start for hybridization. Okay, so today I will tell you some tricks how you can remember the atomic number of halogens. We know that our halogen family is our group 17. So the elements are our fluorine, chlorine, bromine, iodine, astatine and our tensine. So we know that from our basic classes, means 8th 9th standard, we know that atomic number up to 20 we learn. So it is very easy to remember the atomic number of fluorine, that is our 9. And we also know that the atomic number of chlorine is 17. So now what is the atomic number of bromine? So if we talk about the atomic number of bromine, now all students don't know. So what is the logic behind it? As we know that the atomic mass of our chlorine is 35. So just you put the atomic mass of our chlorine is 35. It is the atomic number of bromine. Just you reverse it. 5 आगे लेना है, 3 पीछे. So the atomic number of iodine is our 53. Now what is the atomic number of our astatine? So for astatine, what you have to take? Astatine, atomic number of astatine, how you will write? The atomic number of our astatine is our 85. So what you have to do? Just you reverse this 53 again, make 3 in front, write it here, make it 8. So you can easily learn the atomic number of astatine also. It is our 85. And now again, what will be the atomic number of our tensine? So it is very easy. Just you take our chlorine, write 17 and make it reverse. You know, हम लोग reverse order में 1 2 3 लिखते हैं. Just you write it 1 here. So it will be your 117. So once again, how you are recalling the atomic numbers of halogens? What is the atomic number of our fluorine? 9. And we also know that the chlorine is 17. What is the atomic mass of our chlorine? It is 35. And so this is the atomic number of our bromine. And just you reverse the digits. So it is 53 of iodine. And just again you reverse it and write 35 and make it 8. So 85 is the atomic number of our astatine. And what you have to do? Just you write for the chlorine 17 and write 1. So it is our 117. I hope you will never forget this in your life. So now I already told a song type na, फिर कल बाहर आई आंटी tensine से. Okay, so just you can write the code also, फिर कल बाहर आई आंटी tensine से. So you can also anytime whenever you needed to learn the halogens, as we know that halogens are our salt maker, you can easily remember this. Now I will discuss the geometry of our IF7. Now you know what is the atomic number of iodine? It is 53. So how we can make the geometry? Because now some students a little bit tough hybridization, but if you forget the atomic number, then it becomes more tough. So as we know that we can IF7 molecule is having pentagonal bipyramidal geometry, and it is our sp3d3. So student, one more thing, as we know that IF7, the iodine is our 53 atomic number. Iodine atomic number is 53. And one more, you have to start directly with the it is 5 now, so you can directly start with 5s. This is again you can remember. So for 5s, 5p and 5d, we can directly, for this hybridization, iodine atomic number is 53. So for the trick, you remember this 5 and you can directly start with 5s, 5p and 5d, because we don't have to count from the beginning. So how we will make this orbitals? Let us see here. So for IF7, as we know that our geometry is hybridization is sp3d3. So we will just make s 5s 5p and also our 5d 5 orbitals. Okay, now what you have to do, we have to write first the ground state. So what is atomic, what will be the configuration? So again, for the configuration, just you read for the chlorine. As we know that chlorine is the first member of halogen family. What is the atomic number of chlorine? It is our 17. Or you go for the fluorine, it is the second member, so it is our 9. So for what is the configuration for fluorine? It is our 1s2, 2s2, 2p5. So always remember the group will follow the same. So for the iodine, what will be? It will be our 5s2, 5ps2. So for iodine, what configuration we will write? We will write our, as the atomic number of iodine is 53. So we will take krypton in brackets. It is 36. Then 4d10, 5s2, 5p5, 5d0. I hope you remember. Now fluorine, what will be the configuration? Atomic number of fluorine is 9. So it is our, it was 1s2, 2s2, 2p5. So we don't take the first one. And so just we have to take our outermost 5s2, 5p5 for hybridization, because it is packed up to here. Then 4d10 is also fulfilled. So we will take our outermost shell for hybridization, that is 5s2, 5p5 and 5d0. Whenever we are on the fifth shell, we are writing 5s, 5p, we can write 5d also. Okay, so it's having no electron, 0. So how we will fill? So we can fill 5s2, 5p5. Okay, so we will fill our, this is our 1, 2, 3, 4 and 5. So that's the way to fill the electrons according to the Hund's rule. So it is 5px, 5py and 5pz, and these are our 5d orbitals. We also know that what are d orbitals? 5dxy, 5dyz, 5dzx, 5dx square minus y square and 5d z square. So these are our orbitals. Now for hybridization, what we have to do? So this is the ground state of iodine. So for the excited state, what, how many fluorines are coming? 7. So what we have to do? We have to make 7 orbitals with 1 electron. So what we will do? We will shift these electrons from our 1 to this orbital, d orbital, second from this orbital to d orbital, again one from our p via to our d. So it, then our all the orbitals will have unpaired electron. So our fluorine will come and donate 1 electron to each, and they will form our covalent hybridization of our sp3d3. So we can make single electron each now. Okay, so now for hybridization we have ready 5s, p3 and d3 orbitals. So what s, p3, d3 we need now. So now our fluorine, what is the atomic number of fluorine? Fluorine have 9 atomic number. So 1s2, 2s2, 2p5. So which orbital electron will participate in hybridization? As we know that it, if we write for the p, so it will be px2, py2 and pz1. So for our hybridization, this 2pz which is unpaired will participate in the hybridization. So our 7 fluorine will give 1 electrons each, and we will have our hybridization. As our hybridization will go, so what will be form? IF7 molecule will form, and IF7 molecule 7, you can write here fluorine, everywhere hybridization will take place, and we have this structure that is known as our pentagonal bipyramidal. So what are the bond angles here, students? As we know that pentagon, na? So just to divide our 360 by 5. So what you will get? You will get our 72. So 5 angles which you are seeing with this red and all, so they will be having the 72-degree bond angle, and this bipyramidal will have our 90-degree bond angle. So is if sometimes it is asked in our exams. So what overall we have 5 angles with the 72 degree, and we have 2 with the 90 degree. So this is your IF7 molecule and hybridization. This is known as our sp3d3 hybridization with the geometry of pentagonal bipyramidal. I hope you always remember what is the atomic number of iodine. It is our 53, and fluorine is simple. So thanks for watching. Do subscribe my channel and share with your friends.